Okay, welcome back to the Smart Mobile Studio presentation. I've been doing a couple of these videos now, but hopefully we can do a more substantial look at things now. Okay, how are things going? Well, we have gone through some of the grid stuff, and it's getting there. Still a few tidbits to fix. That involves, and I can show you, that involves well, don't bother about the green here. The green is basically the background. It's just to see how fast it manages to, populate each row, because it creates each row as it moves into the list, so to speak. It doesn't try to create every item before showing the display, because this is faster. But what I wanted to show you was, of course, the set index. You can see I'm logging all the set index here, so that each element that is created gets a set index by the document object model by default. The problem is, of course, what you see here, and that is that this set index is not localized. Normally in Delphi or C++ or C# or whatever, the set index is calculated from the parent. So if you have a parent element and that has a couple of children on it, those will have set index 0, 1, 2, etc. But here you have a global set index, and this is because, of course, that in the document object model, the document itself is the root parent, and this is why this is happening. So I've started to basically create a mapping system that will allow us to emulate, if you like, the same behavior that you have in Delphi. So that will be in place quite soon. But you can see you can move things around. I took away all those fancy effects because it's basically just a waste of time. You can add them yourself if you want to. But yeah, it's getting along. I've also done some speed tests, and right now this is more than usable on a iPad 2, but it's still not optimal. It's not where I really want it to be. So I think we're going to simply call this a desktop DB grid, which means that it will be perfect for HTML5 applications that is designed to run in a full screen or desktop browser. It actually doesn't even have the touch and momentum scrolling, so this is better suited for like a normal Windows application or something like that. I've then started on a more iOS and Android mobile device type content scrolling thing, database grid that you can use there, which has, of course, touch, and it also uses the GPU to move things around. So it's a hell of a lot faster. So yeah, but of course the more interesting parts now are the client and server projects, which you can now make. So this is a WebSocket server system. Now don't worry about all those includes. I just included everything, makes it easier to work with and stuff like that. But naturally, you don't need the HTTP, you don't need the UDP and stuff like that, just to have a WebSocket server. So this is very simple. It's create a server object, WebSocket. WebSocket supports two types of messages. You have a text message and also a binary message, so you can send binary data. And these are separate. In the JavaScript version, they're not really separate, but one of the benefits of having Object Pascal and also the runtime library that we have is that we can actually, check for the data type. So the moment we get some data in, we check for the data type. Is this binary data? Is it anything else but text? If it's text, we fire this event. If it's binary or undefined, we call this one, which makes it so much easier to work with. And then it's just a simple class. You create the socket server object, you hook up the events, and then in the run method on the server, set up the port, client tracking. Now, client tracking is a bit special. Just a few words about that. Node.js allows you to do client tracking, and that means that it will retain an array of connected clients, basically, in memory. So you can do stuff like, for x equals 0 to count -1 or something. So you can basically go in and check, what clients are active now. If you want to pinpoint or find a specific client, you can do that. So it resembles, a session object in Delphi. If you've ever worked with stuff like rem objects or something, then you know what a session object is. So it can resemble that. So we set that to true. You can, switch it off if you don't like it. And then it's just a matter of activating the server, and then it will start listening on this port. So let's just kickstart that. Oops, I already had one running. Okay, execute, right. Okay, so just going to leave that alone and quit or close the project. It's still running in the background because we just fire up Node with the project. And then we can go to the client, and I'm sorry, but this defaults to the old iOS look and feel. You can of course change that in the project options. Go in here and you can set a different CSS, but in the designer it's sort of stuck with this, and that's one of the things that we're going to rip out and completely remake, because this is it's not working. It's not even close to what I would like to have. So but that we have to live with that for now. But after the RTL update, this is basically going to be one of the main focus areas, to get that WebKit live rendering back. And yeah. Okay, let's compile the client, execute, voila. Let's see if we can connect to that one. Got the server running right here. Connect. Voila, we are connected. So yeah, I don't do any logging on the connect part. So we can just write this is a message and send message. Okay, let's see. This is a message. Voila. And I seem to remember connected. No, I didn't dump it out. Okay. Blah blah blah. Send. Yeah. I used to have a dump here that it would dump out the text it received and also the text that it would send back, but I removed that for cleaning up. But at least you see that the server is now getting the data, and it's also sending a reply actually. So so that's nice. Let's see if we can change on open on close. So on click. Yeah, this is different. We need to set up an event handler. I'm not going to do that now. But now you have a server that is active. And of course, when you're creating a professional server that is supposed to, be uploaded to the cloud and be hosted at Amazon, for example, then of course you would write a lot more code that has to do with security and access rights and double checking everything like you would do in any server. But this server is now scalable. You can also wrap it using there's a system that is actually written in Node.js itself called PM2, which is basically Process Manager version 2. And this allows you to processify, if you like, your running code. So you can turn it into basically a system service. So you can start a service, you can stop it, you can make sure that it starts with the system as Windows or Linux boots up. So you have a much finer control over the server process or client process or whatever. So that is, we take for granted that you're basically using something like that. It also has a really cool feature, which is of course the fallback feature. If something should happen, and of course JavaScript is it's very sensitive, a tiny mistake and it will of course exit. And this is where the PM2 really shines, because it will then restart your service automatically. You can also make it more fault tolerant and do automatic logging and these things. The coolest part of PM2 is of course that it deals with clustering for you. So if you have a system, let's say you're running on Amazon, you have a system, let's say an octa-core 8-core CPU, then you can, with a simple command line, instruct PM2 to run this service and run it clustered on the CPUs. You can also daisy chain things. So let's say you have the same server installed in 500 Amazon instances. And you can daisy chain them and basically just set up clustering, the traditional way that we're used to dealing with clustering. So that's pretty cool. So that was the server example. So and I also thought I could give you a little look behind the scenes. Now, this is actually Delphi running inside a virtual machine, and here we have the source code for Smart Mobile Studio. I just wanted to show you just how much work this is. This is not like something you slap together over a weekend. It's a huge code base, and we're talking roughly 4 years of continuous work getting this to function the way we want it to. And there's a ton of code in this, so I'm sort of jumping between the scenes here. So you have the native side, and then you have this side. And this is an older version, by the way, 2.2.1, and you can see that because it's still drawing the background here wrong, which is one of the things we've actually fixed, which is going to go away. We're also going to do something about the look and feel of things here. So this is how it should have looked. Sadly, this is how it ended up due to a mistake. But that's how it is. So yeah, things are moving along quite nicely, and I'm going to focus on the set order or the set index to get bring to front and send to back methods, so that they will work as they should. And well, that's a little update for now. I hope you find this interesting. We have put a lot of work into this, and the runtime library is huge. We're talking a huge amount of units and code and classes that are ready for you to use. So yeah, I hope you like this. Okay, goodbye.